Hello and welcome back again to another video of our Turing Complete series. We are going to re-enter the campaign. Oh, we are straight. Yeah, put into a level. We are updating the Galactic and Encyclopedia of Food instead of human foods. As we don't have an alphabet, entries in the encyclopedia are ordered by deliciousness. First read the 15 deliciousness scores from the input, one by one. Your task is to output them in sorted order, smallest to largest. Okay, so we are going to have to sort these numbers from smallest to largest. First of all, I don't know, I didn't mean to enter this level right now. So I just deliciousness order. I mean, we could, right? The RAM would be amazing to do this, but having a stack as well would be a great thing too. I actually kind of want to finish the architecture before we start programming. Anyway, let's just do this. We're updating the Galactic Encyclopedia. Yes. 15 food inputs. Okay. So let's see. We've defined a lot of instructions already. So let's see how far we'll get. We will move input to RAM, and then we are going to add 1 to our RAM address and save it into our RAM address. Right? This is going to be thing that we will do until the RAM address holds the value of 15. So while it is less than 15, we're going to import. So this way we would have, let's see if this works. Then we would have to, probably, I don't know if this would work, right? I mean, in theory, we would have to have a way to, let's just do it like this. Immediate value 2. So this should read all of our values into our RAM, right? Let's see how this goes. So the last value should be 199, and apparently it is, which is great. But we've added 1 too much. Is that a problem? Not really. We'll just let us define sub I. Sub I is a very valuable command, I guess. So the question becomes, do we sort them while importing? Which is probably the most and then export. We do this while export. The RAM address is greater than what is this? Sorry, my keyboard isn't working. Now it is. Greater than or equal 0, right? And we would probably just do it like this, don't we? So this is going to give us the wrong. The wrong result. Because these are unsorted. Okay, we can... How do we do this? While importing, move in to RAM. We could check where it goes, right? I mean, we could do this by saving our RAM address. To a different register. Let's say we put it into R1. After that, we move zero to our RAM address. And then we check. Okay, we wouldn't move the value into RAM. First of all, we would move it into our check register. Which maybe we could... Oh, it is not defined, it is constant. Our check. I would define it as, I don't know, this should be register 5, right? No, it actually is register 4, since we have register 0 as well. Let's put it into 4. So, first we move into our input into our check. So, now it sits in our check. Now, we move RAM address to our 1. Let's do it like this. Okay, so now we have our current RAM address sitting in our RAM buffer. Now we move 0 to RAM address. Now, what do we do? What did the level want us to do? Did it want us to output the most delicious one first? Smallest to largest? No, the most delicious one last. Okay, see what. Yeah, we can check against the RAM buffer. So, okay, one of the checks is if it is less than or equal the RAM ADDI, then our RAM buffer we would import find position. Okay, 0 is put into our RAM address. If the value, we'll have to find a pass. So that would mean, first of all, we would check if the value is greater, we would move on. If the value is smaller, we would place it. Let's go with less than or equal. Even though there seems like there are no two equal values. So if the value that is sitting in our check is less than or equal the value that is sitting in RAM, then we would place it. And how do we do this? So this way we find the position, right? This is going to be, we would have to take every value that is, like we have the RAM buffer, right? And the RAM buffer saves our current number of saved values in a number, basically. And we would then have to take the difference between the position that we determined in find pass, and then we would basically move every value that is left that is still greater. It's probably better to sort it the other way around, but because then we wouldn't have to rewrite our export function. Move them one to the right. And that is, well, the best thing to do this is to take the RAM buffer, put it into another register. Let's go like this. Let's call it delta RAM. Because the delta, if you don't know this, the delta is like is usually used to describe a difference. And move it to, we could also call this copy because it's not going to the need though. Initial value. What we're going to stay with move. All right. So now what? We have our RAM delta. That is not true. We move RAM to delta RAM. And we do this while RAM is less than or equal to delta RAM. What we are going to do is we take the value that is currently sitting in RAM. Let's do it like this. Let's call it variable 1. Let's go with 8. Then we're going to place or check. This is not how it's going to go. Into the RAM, we can do it like this. It's fine. It's not the most clean variant, but So okay, now the value is going to sit basically in the correct position in the RAM, right? But we still have var1. How do we fix this? Now we move var1 to rcheck. Because this way we are going to ensure that this piece of code is going to work. It's basically two variables, right? We take one out of the RAM, put it into variable 1, then we take the one that we have stored in rcheck, put it into the RAM, then we move one forward. No, then we move the other one back to rcheck, and then we move one forward. Take it again, put it to R1. Yeah, var1. And this repeats. So I guess, yeah, this is going to work. So that means this is going to work to place the value in the correct position. What is the next thing that we would have to do? We'd have to go back to find position. So the way we define it is a version that needs us to basically skip this part. And jump to export once we have finished. We have always. Let's see. No, we don't. I guess we want an always variant. Now this is very handy. Well, the fact that we still have open slots, right? Zero, 1, 2, 3, 4, 5, 6. Six is going to give us basically always. This is condition, right? Oops. Yes. We can define it in our instructions as well. Isn't that cool? First we create a circuit that does what we want. And then we define it. Now we can go like this. We can use it then. Once we reach this point, we have read all the values. Then we jump to export. And the values are not going to be important, I think. It's going to try to no, it's going to do nothing. You can also define an empty. And then program it like this. So we'll jump to export. Once we're done importing, this one we find the position, this one we'll place. Once we've found the position. Once we've placed, we go back to import. And get the next value. Find the position. We already got kind of lost track. Let's see. Does this solve the level already? No, it does not. Oh, because we never... Okay, let's step through this one by one. We move RAM address. We move our RAM address to the RAM buffer. Then we move 0 to the RAM address. Where's the RAM buffer? The RAM buffer is 4. The RAM buffer should be 0 anyways. But it's 251. How's that? Wait a second. We move in to our check. Oh, our check is register for. This is why now it makes all sense. So now we move RAM address to RAM buffer, and RAM buffer is actually 2, and there's a 0 in this. This is correct. Now we move 0 to our RAM address. And now we check if it is less than or equal. Now our check, which is the imported value. Well, if it's less than the value that we already saved in RAM, we go place it. So since there's a 0, there will always be less. So we should place. We don't. Why don't we? So here's the problem. Here's the first problem. How elsewise we add 1 to the RAM address. And this should loop through the entire RAM. No, it is not, it just has 1. Oh, because now the RAM address is, oops. We can do it like this. No, we can't. First we take this, then we move 0 to RAM address, and there's the B. Second version of this. Which cannot be here. I made a mistake. We take our value, put it into our check register. Then we move our RAM address to the RAM buffer. And we move 0 to the RAM address. So far everything is fine. Now we check if the value is lower, less than or equal than the value in RAM. It should check. The question becomes now, maybe we should solve this first. Why? Then we jump to place in this case. Why are we even comparing against 35? Oh no, this is the opcode. We're comparing 251. The condition is not met. How is that? If the first value is less than or equal the value in RAM. Oh, this is not less than, it is greater. Yeah, let's do it like this maybe. If it is greater, place it. So now it should work. At least this part, right? We're still going to have to increase the RAM address at some point. So now we move RAM to var1. Where's var1? 8. This is a little bit confusing. Yes, this is a 0, it's supposed to be a 0. Now we take variable 1, put it into our check, it is 0 anyways. This is RAM. import the next one. So 251 should be sitting in the first position in our RAM. Yeah, this is correct. Now we are going to get a problem. Because before we import, we should see what this will do. No, it will not work. Okay, there are a few mistakes, but the video is already 30 minutes long. And it's a little bit unfortunate that we didn't manage to finish the level. But we are going to come back to this level and we're going to finish it. Hope you had a great time. Maybe you already found the mistake and thinking, where the hell is she not able to find it? I have no idea. But yeah, maybe let me know in the comments. So goodbye for now. This was IV42.